So as I mentioned before, I'm Barbara Cohen. I'm at NASA Goddard Space Flight Center. I am the project scientist for Artemis IV, and Dr. Jen Heldmann at NASA Ames Research Center is the deputy project scientist. And we're both going to be here with you all day. We have talked in various forums about the science, the way that we incorporate science into the missions, the way that the SMD science process goes. But we recognize some of you are new here and you may not have heard it. And so we're going to talk about the way that the progress goes and then also the specific progress we're making for Artemis IV itself. So let's go to the next slide. So NASA's Moon to Mars Objectives is a document that I highly recommend everyone go read. It's a distillation of all of the documents that we use in science planning. So things like our decadal surveys, different roadmaps, community documents, community prioritization documents, all of these things that you're all working on for the benefit of science. All of these were wrapped up into these Moon to Mars objectives. So I promise you there's a mapping in each of these objectives to things that you are all familiar with. The benefit of using this document is that ESDMD and all of NASA are using this document to plan for our Moon to Mars and our Artemis program. So instead of trying to ask every individual engineer to go find the planetary science decadal survey and the heliophysics decadal survey and the League exploration roadmap and the SCEM report and all these things that we're familiar with, we've asked them to use this document. Everyone has agreed to use this document. And I promise you all of the objectives that you know and love are in this document. So you'll see this referenced a lot. When we plan our science, we're going to trace directly to these Moon to Mars objectives. And I hope that you all see yourselves and your science and the things that you want to accomplish in this document. Next slide. So as I alluded to in the beginning, the Artemis IV specific opportunities are going to be very similar to what we see in Artemis III right now. You're going to hear Jake talk and the next talk about the specific architecture and the uncertainties that are coming up with that. And as NASA's planning for those and trying to decide how what architectural elements it wants to use and how it wants to build those vehicles, that is a little bit tangential to what we're talking about here. What we know is that there will be another mission after Artemis III. It will go to the lunar surface, and it will have roughly the same opportunities that Artemis III has. And just to highlight those as things that are of interest to what we're talking about today, the SpaceX Starship will be or is currently planned to be the lander. So the capabilities that Sam talked about before about the vehicle performance and things like that, hopefully we'll know a little bit more after their demo mission and their Artemis III mission. The science and utilization is what NASA, it's kind of NASA jargonese for what we'll think about as science. Science isn't the only thing that's in utilization. Utilization also includes things like the human research program. So when you're taking like blood samples and saliva and checking out how much the astronauts breathe and things like that, human research program. It also includes things like public affairs and office of communications. So when we want them to plant a flag and we want them to take a picture and talk to the president on the phone, those are also things that the crew are doing or that the architecture needs to accomplish, vehicles need to do, crew needs to do, things that need to happen to accomplish goals. Those are utilization. So sometimes you'll hear us say utilization and sometimes you'll hear us use science. For the purposes of today, they're kind of interchangeable. But those capabilities that we're going to have available to us, those resources that we're going to have, the crew time, the mass, the tools that we have, the ability to take pictures, the ability for crew to make observations and talk to us, those are going to be broadly similar. We'll have opportunities in transit and orbit for crew to look out the window. That's IVA, inter-vehicle activity. Things like looking at the full disk of the moon, looking at Earthrise, describing to us what they see. There may be things like impact flashes. There may be things like dust lofting on the limb. There may be really interesting opportunities to see polar sites before they land and describe them in new and interesting ways. It will be a roughly South Polar Landing in the South Polar region. So that is the region that we're going to, defined pretty broadly as 84 and south. It'll be about a 6.5 day surface mission with multiple on-foot extravehicular activities or spacewalks, moonwalks, walking out to about a 1 kilometer radius. And sample return is what we would call unconditioned. There's no freezer capabilities or anything like that we're planning for in future missions. Artemis 4 won't have those quite yet. So we won't have mobility yet. We're still on walking distances. And we're going to return ambient samples. So those are the basic parameters that we're working with here. Next slide. So science planning, the way that we do this is that we have our NASA team working really hard. Remember that NASA scientists are part of the community. We all go to the same conferences that you do. We try to publish our own work. We are members of your community. We're all working on this together. So just because we're badged to NASA doesn't mean we're off in La La Land working something that's behind a black box that you don't know. You know us. We are part of your community. We are the team that's working really hard to plan these for you in the beginning, and then to be able to take the feedback that you give us and your ideas. So we're looking across the mission capabilities to plan out sort of our big picture strategy across all Artemis missions. And then the leadership, Jen and I and some other folks at SEO are working on the specific inputs for Artemis 4. What that goes into is something called the mission priorities document. That's across all STMD, SMD, ESDMD, aeronautics if they're interested, right? All of the mission directors get together and say, how do we want this mission to go? So that summit is coming up next year. So all of this is, you can consider it very much pre-planning, very much pre-planning. Nothing is set in stone. So don't get hung up on the specific words we're using. I just want to give you a flavor with what they are. Some of the other things, of course, that we do is we bring on teams competitively as we go through this. And that'll look very similar to Artemis 3. We'll have the Artemis 4 deployed instruments. They're under the process of being selected now to meet those development timelines for our launch. Even though some of the science you're going to see planned here, I want to promise you there was no hidden criteria for Artemis 4 deployed instruments. All of the things that you submitted as a community fit into our science goals. There were no hidden criteria. Handheld instruments are something that SMD really wants to consider and really wants to bring into the fold for Artemis missions in general. Those have to be planned within our budget constraints, so we don't see that in the FY26 budget, but we are still hoping that we're going to have those come on for Artemis missions, possibly as soon as Artemis 4 or possibly later. Our tools contract is coming up in FY26, so we're going to be letting out a contract for the geology tools. So we need to do a little bit of planning now to say what those geology tools are, but they're going to probably be very similar to Artemis 3. So we're getting requirements into that process to hopefully evolve and learn more about what we were able to do with Artemis 3 and evolve those and do better for Artemis 4. And as Sam said, this landing site process is underway. We're in the very early stages. We're in step 1, but we can see where it's going, right? We can see that they're going to need figures of merit, that science as a player is a part of that process. And so that's why we're planning this now, so that we can be a strong partner from the start. Okay, next slide. So this is an eye chart, and I don't expect you to read it. I just want you to see that we're going to go through some of the possible science measurements and priorities for Artemis 4. Artemis 3 has something similar to this for site agnostic science. It'll be our first time returning to the moon. There's a lot of things that we want to do that we can do at a lot of different landing sites at the South Pole, looking at polar regolith, looking at possible volatiles, things like that. Artemis 4, if you go to the next slide, Artemis 4 is going to sort of try to go into our bigger picture strategic goals and start digging into those across all Artemis missions. So one of the things that's been a big strategic goal for us for a long time in science is the South Pole Aitken Basin and the unique science that it affords us. It's the largest basin in the solar system, the deepest, the oldest, possibly the oldest, certainly the oldest on the moon. And the way that it affected the moon and the way that it affects all of the landing sites and samples that we've returned is really important. So it really is a cornerstone to all planetary science. It's been called out in multiple decadal surveys and multiple strategic reports. And it happens that the Artemis landing zones, or places that we could select for landing are on the rim of the South Pole-Aitken Basin. So we want to try to use this to the best of our ability. We've got an opportunity to look at the structure of South Pole-Aitken Basin, to look at the materials that came out of it, and to do the geochronology that we all want to do to understand the formation and the age of South Pole-Aitken Basin. So that's going to be theme 1 for our science, and you'll see a lot of that today. Next slide, please. Some of the other theme, I just want to say too, of course, this is a big topic. South Pole-Aitken Basin is a big place. It's a complex place. It's an old terrain. It's had a lot, 4.5 billion years or something like that of geologic processing. There's no one mission that's going to solve the mysteries of the South Pole-Aitken Basin, and it's folly to say so. So Artemis IV is a way to take a bite out of it, but it is not the only way. And certainly it does not displace planning for anything else that we're doing, including things like endurance or other forms of sample return, like they're called out in the New Frontiers missions. So we'll hear more about the complexities of the South Pole-Aitken Basin as we go through these talks, and you'll be able to see the broad range of science. And what we're asking you to do today is think about the way that Artemis IV specifically can take a bite out of the science. Not all of the science that we can do, but for the opportunities that are afforded to us by Artemis IV, what can we do? Next slide, please. So some of the other themes that we're working on that may have landing site figures of merit that you can be thinking about, but we also have lots of other science that we want to do, enabling safe human exploration by modeling the biological systems of the crew to be able to provide them with better health solutions, protecting them from the rigors of space, and then understanding the microbial environment. The built environment is going to harbor a lot of microbial life. Obviously, how does it transfer between surfaces? How does it live? What is it? How does it move around? Next slide. Characterizing the modern lunar and cislunar environments. How do we keep people, vehicles, assets safe in the cislunar environment and beyond as we're thinking about how to go to Mars? How does the space weather environment affect us? How does it affect assets and vehicles and machinery? And we already have some gateway instruments that are going. Gateway may be part of our solution. So those are selected down there, as you can see. There's other science that we want to do. We can think about things like collecting regolith and looking at the solar wind, doing other kinds of heliophysics monitoring radiation environment. Next slide. And then enabling science for a sustainable future. So these are things that maybe we can be looking for resources, the science that's behind resource use and distribution, how things got there, the science that's behind the formation and evolution of lunar materials so that we can predict where they are if we ever want to use them, and other sorts of applied science things that we might want to do using the natural laboratory of the moon as the place to do those things. So those are kind of the broad buckets. I hope that you find something good that you like in one of those. So next slide. So that is our very early planning, like I said. Really, the South Pole-Aitken Basin or the early lunar basin geochronology focus is what's driving our site selection workshop today. We know that there are places that are maybe better or worse to do that kind of science. There are also figures of merit that you can think about for all the other science as well. We don't want to preclude any of the other good science that might be selected or proposed by you as you compete for these opportunities. So that's what figures of merit are to us. What are good landing sites? What makes a good landing site? What can we put into the process that Sam described to get the best science we can, or get the best places to achieve our science that we can? So things like materials that can be returned for geochronology, understanding the full geochemical signature of materials that have been thrown out by SPA, understanding what that rim or the subsurface structure might be, where the rim is, or what that geophysical underlying basin structure is. And then high science value for our other science investigations may also be included in figures of merit. Maybe we want to have things where We can be looking for cold spots or where volatiles might be, or where there's good solar wind interaction for understanding the solar wind. So those are all things that we're asking you as a community to help us figure out and put those in the hopper so that when we are doing our landing site selection process, science is the best represented that it can be. All right, and my time is up. So thanks everyone. And we're going to turn it over to Jake Bleacher, who's here from ESDMD, and he's going to give us some Artemis updates. Thanks, Jake.
Hey, can you all hear me real quick? Comp check.
Yes, we can.
Great, thanks, Ricky.